Welcome everyone to the experiment where we study the oxidation of iron to in aqueous solution. In the first step, we bring together all the chemicals, all the materials for the experiment, and all the auxiliary material which we need to prepare samples to put them together on the bench. And in the first step, we want to show you how to prepare the solutions, and in particular, we look here at the solution preparation of the iron solution. And remember, we need the 2 millimolar of iron 2 solution. For that, we take the iron chloride. Okay, we calculate at home the amount which we need to prepare this solution. We then weigh out in the balance. Balance uses a weighing boat. This weighing boat has been added and the tara has been taken, and we note down exactly the amount of powder which we've taken. Now we have to prepare the solution where we dissolve it. So that's a mixture of water and HCl. So in that case, we use here an Erlenmeyer vial. We add a little bit of water. Okay, it doesn't matter. We don't need to know how much. We just add a little bit of water. Then we need to add the amount of HCl to get the concentrations we need. That has to be an exact volume, okay? And then we go over to the balance. We take the tara again, of an Erlenmeyer vessel. And now we have the water with the HCl, and now we add the iron chloride. And we very carefully use water to rinse everything off, okay, carefully. And then we add the water to the amount of grams which we need. Okay, very carefully. Okay, we have here 250 mils, and we see here we try to get exactly 250 grams. It doesn't matter really how much it is, we just write it down, and because we have the weight of the iron chloride and of the water solution, so we can calculate the concentrations. And then we put it into the dark box, okay, so that doesn't get oxidized.
In the next step, we are preparing the calibration standards for the iron 2 measurements with the UV-Vis instruments. So in that case, Dewey already prepared the different solutions needed. He calculated the amount of the different solutions needed using the Excel sheet, and now he prepares the solution. So he takes the amount of 5 milliliter water and adds them into the tube of the calibration tubes, calibration standard. He then removes the amount of water which will be added when we add the phosphorus stock solutions. This amount he removes so that we have the right volume at the end. Okay, so for each standard there's a different amount of water which he will remove. And then that volume which has been removed, that will be added afterwards with the phosphorus stock solution. Before he adds the 1 milliliter of acetate buffer and the 0.1 milliliter of Ferrozine. And then he adds the iron stock solution, and the amount he adds obviously depends on the concentration of iron 2 plus he needs, and that's the amount which you calculated in your spreadsheet in the table shown on the computer. Okay. Okay. And once he has added the iron 2 plus the stock solution, then the complex will form in the solution. Okay, we will form iron ferrozine complex, which is color, and we will measure the absorption of this complex, of the color, using the UV-Vis, exactly the same way like we did for phosphorus in the experiment 12, where we looked at the absorption isotherms of the phosphorus. The next step is the calibration of the pH electrode. To this end, he uses the Metron pH meter, okay, and measures the potential of the electrodes in different standards, different solutions with different proton concentrations and different pHs. He takes it out of the storage solution, rinses it very well with water, takes the water off very, very gently with the paper, and that puts it in the first calibration standard. And you see here that it has a potential of 172 millivolts in the pH 4 calibration standard. Once it's stabilized, then he puts the number into an Excel spreadsheet, which he already prepared and computer took into the lab. So here he adds all the calibration numbers. He gets then a nice calibration curve with the regression, okay? And he uses then the Excel daily nest function, which actually calculates for him the slope and the intercept, gives also the error and the R squared, the Pearson coefficient, so it tells us how good the calibration is, and then he uses the slope and the intercept to calculate the pH at a given potential, which he then measures during the experiment. Okay, so you can do that directly in the lab with your computer. And now we conduct the experiment. To that end, the first thing what we do is prepare the test tubes where we will add our iron 2 or our solution from the experiment into. To this end, we will add all the reactants which we needed for the calibration curve. We will add here. So we add Ferrozine and we add the acetate buffer in the test tubes. Once we've done that, we weigh out 250 milliliter of water and put it in our reaction vessel. Here we have the reaction vessel. That's where the oxidation of the iron 2 will happen. Now, the first thing what we do, once all the water is in solution, we switch on the water bath, and the water bath that helps us to fix the temperature of our reaction solution. Okay, the water, you see, goes through the jacket, and then basically heats the water to the temperature which we want. In that case, it's 25 degrees, so that's all up and running. And now we prepare all the solutions, or prepare all the solutions which we add to the reaction vessels. In that case, we need imidazole, that's the buffer, then we need a base and an acid to adjust the pH. We add the electrode into the vial, okay, so to measure the pH. And then what we will do is put the magnetic stir so the reaction is solution is well mixed. We do, in the next step, we add the imidazole, our buffer solution, okay, which ends up then roughly at pH of 6. And then in the next step, we use either the acid or the base to change the pH to the pH which is desired. Now we add in a tube with air, okay, and bubble the air for about 8 minutes. Now, the idea is here that we add oxygen, obviously, into our solution, which then acts to oxidize our iron 2. Now, once the air has been bubbled, we add the iron 2 plus and immediately start to take the time. Because now, obviously, the reaction happens. So the iron 2 reacts with the oxygen in solution, and we take at the time intervals which we decided to take, depending how we planned our experiment, so to the solution. And during these time intervals, of course, the iron 2 concentration will decrease, because iron 2 will oxidize. And depending on the pH, this reaction goes fast or slow, and you will get a series of different iron 2 concentrations, and therefore a series of different colors. Then, once we've done this experiment, we transfer the solutions into cuvettes, which we use for the UV meter. On the left hand, you saw the calibration, the solution for the calibration curve. On the right hand, you saw the samples from the experiment. We take then the solution without iron 2 and use that as a baseline. Okay, so we measure that, set that to 0, and then we start to measure first the calibration curve and then the samples. So in that case, that will be the first calibration curve, and it has an absorption of 0.047. Once we've done the calibration curve, we'll measure the samples. You see the increasing absorption with increasing concentration. So now the calibration curve is done. Here you see the calibration curve, okay, with the different concentrations, and now we can measure the samples and then know the concentration using this calibration curve.